So we finished up with talking about the formation of cute little snow crystals. And I thought you guys, when it was snowing so much, I'm like, oh my gosh, how neat is that? But oh, I'm so ready for it to stop snowing. Okay.
I want more.
Hey, stop snowing, then next day we're supposed to have freezing rain.
I know, I agree. It's like,
I'd rather have snow and freezing rain, that's for sure.
but what snow and freezing rain have in common is their precipitation. So anything that falls from the cloud is generally called precipitation. So dew is not precipitation. Frost is not precipitation. So we have these different scenarios, and I like what your author's done. It starts with letter B. What do we call that up at the top in the clouds? Makes snow? Bergeron process, exactly. Okay. So we have Bergeron going on up there, but depending upon what the temperature is as the snow falls, we might get it as rain, okay? So we're probably okay with this. What your author did over here is basically, this is showing a profile of the temperature of the earth as basically the stuff falls. So the blue is cold and the pink is warmer. So this would be frozen and this would be melted.
Melted.
Yeah, exactly. So that's cool. We get rain out of those. We still call those cold clouds giving us rain. This would be cold clouds giving us snow. Okay, so basically it just has to stay, cold enough as the stuff falls to the ground. Okay, cold clouds from the Bergeron process giving us snow. Okay, then the next two kind of go together. The other two forms of precipitation are sleet and freezing rain. Sometimes freezing rain is called glaze. Okay, and that's on the next slide. But what they have, both have in common is a temperature inversion. We talked about temperature inversions before. The word inversion means kind of flipped. Can you see this warm pocket of air kind of right here? Okay, this warm pocket of air. Basically, it falls as snow, it melts into liquid, and then, of course, the Bergeron process can't happen here when it just basically refreezes. Okay. So temperature inversion says basically as you go up in elevation, it gets warmer. Can you see as we're going up in elevation here, it gets warmer? And then it gets cooler. So the temperature inversion is kind of the kink part down here, kink. This is a temperature inversion. And we'll be talking more about those later too. Temp inversion. Because as you go up, okay, it's getting warmer. The slant is going warm. Okay. So this will give you sleet, and I don't know if you can, I want you to compare this slide figure to the next figure. This is actually a pretty deep inversion. And what I mean by that is there's a fair bit of time for the stuff to pelletalize. I don't know if that's the right word. Basically to form a pellet. Okay, so compare that one, which gives us sleet, to this one, which gives us freezing rain. Glaze and freezing rain are the same thing. Okay, so if you compare those slides back to back, notice there's not as much time down here for it to refreeze.
So it doesn't pelletize, but since it's colder when it hits it.
Right, it doesn't pelletize, but since it hits things, cold things, and it freezes on contact. Okay, so freezing rain is, I think, worse than sleet, right?
But glazing is due to compound ground being colder when the rain hits it.
Right. It's cold, but it also has to be cold above here to kind of sustain that.
Yeah,
Otherwise, it would freeze and melt right away.
But you have to have both to be combined.
Yes, a cold object and the cold air.
Okay, thank you.
Is the rain super cold water then?
I've thought that too before. I'm not sure. I think she raises a good point. I'm almost wondering if this is super cold water, and we could Google that. Super cold water and freezing rain. To me, if it hasn't pelletized, is if it's still a liquid.
Right.
But remember, anything that's super cooled, if it is, I'll put a question mark. Super cooled water, question mark. If it is super cooled, it's just itching to come out of its liquid state and solidify.
So the
almost a
Well,
sludge.
the agitation would be it hitting the cold object.
Yes. Yep, the agitation kind of brings it out, and it really sets you up for freezing on contact.
This might take it off back to freezing, but how does hail fit into both these scenarios?
That is coming up, and hail is totally different. Hail is also precipitation.
Yeah, it's a hard subject to bring water condensation, yeah. That's what I'm
And-
saying, because they fall into both categories.
Yep, yep. And hail only falls from storm clouds. You'll only get hail from cumulonimbus clouds. And hail has to do with when we talk about severe weather, yeah, we're going to talk about an updraft and a downdraft, like we talked about spotter
Okay,
training,
I
up and
understand where
down.
you're going with
And
that.
hail does this.
Yeah.
So hail's on a recycle mode, kind of. Okay, so switching gears now. So the whole thing that we just talked about, those 4 scenarios, the Bergeron process occurred at upper elevations, okay? And that was actually a cold cloud, gave us ice crystals, which may or may not ultimately fall as snow, depends on what the ground temperature is. Now, in warm clouds, we have this different sort of scenario. It's not the Bergeron process. In warm clouds, basically it's liquid up there, in general, and we have what we call collision and coalescence. And it's actually a stepwise thing. Collision, collide, you see the word collide and collision. And the word coalesce means to kind of take in. So basically you have one drop that's basically taking in little drops. Collision, coalescence. And we talked about the 2 types of cloud condensation nuclei. The ones that love to get the party started, hygroscopic or hydrophobic is the opposite. Okay, so collision, coalescence. So to help explain collision coalescence, we need to kind of look at this thing called terminal velocity. So I think I might have mentioned before that the other day when we were looking at cloud droplets, liquid cloud droplets, there's an assortment of sizes. And I said, now that's important for us to get rain. And this is why it's important for us to get rain. So if you've heard of, if you take physics, they will tell you if you drop an object, it will go faster and faster. It will accelerate. Speed will accelerate 9.8 meters per second for every second it falls. It'll just go faster, faster, faster.
Until it meets its maximum velocity.
Exactly, till it meets its maximum velocity. And its maximum velocity only exists because there's air particles, there's resistance, yep. If things were falling in a vacuum, that would be it. But things aren't in a vacuum, it's got air resistance. Exactly. So the thing is large things will have with regard to rain droplets or water droplets, will have a faster terminal velocity. The smaller ones will have a light terminal velocity. So basically, the little ones here in a minute, you're going to see, think of them as kind of just falling down, kind of like mist. The heavier, this is going to be collector droplet. This one's destined to fall from the cloud, okay? That's falling faster. Okay, so think of collision and coalescence. But here's a few kind of typical speeds. The smaller one, it's the top. If you look at that last column, it's falling at 0.006 miles per hour. The large raindrop that can actually fall from the cloud is 20 miles per hour.
That's crazy.
Yeah. So, and everything in between. So, yeah, there's quite a difference. So the large ones fall a lot faster than the small ones.
That's why freezing rain hurts when it hits your skin.
What's that?
So that's why freezing rain hurts when it hits your skin.
Yeah, that's right, because they're going fast. Exactly. Like, dude,
Just smack me upside the head with 20 mile an hour rain.
no doubt. So, one of the things, and we'll really talk about this in severe weather, even before we get to severe weather, but everywhere on the earth, there's kind of this gentle, it's called an updraft. And it kind of occurs because the air is thicker down here and thinner up there. Higher pressure, lower pressure, so we kind of have this little updraft going. Doesn't it just kind of make you feel like the air must be nice and clean because we have this basically a movement of air. So in order for a drop that wants to fall from the cloud to fall as rain, it needs to kind of, gravity is great, but it needs to kind of overcome this updraft. Okay, so there is a mass issue before it can fall. So updrafts. How's what?
It says it's 100 times larger, but 1,000,000 times more massive.
It's because of,
Are you actually talking about mass in the second one?
yeah.
I just think of large and massive as the same things.
The volume versus
Gotcha.
mass, yep.
Okay.
All right. So, collision coalescence. So, can't remember if it made it to your review sheet, which means it made it to the exam, but probably. That's how we get rain in a warm climate. Collision coalescence. Yep, collision and coalescence. Yeah. But here's one for you. If you can read this kind of description down here, but have you ever like seen something floating through, it catches your eye, it's like a feather or a piece of dust or something just kind of floating down. And our tendency is to, that thing needs to go to the trash can or something, or I want to play with that feather. So you try to catch it, and then what happens? Yeah, it scoots away. Like, dang it, it scoots away. And kind of, exactly. As you move your hand, you're creating basically what we call a high pressure here, and that is actually creating a little mini wind. Think of it as creating a wind, basically. So the thing you're trying to get has
It's
a
like
wind.
when you swat a candle with your hand, like the plane moves.
Oh, yeah, that would be good. The same simple thing, yeah. So, exactly. So this whole, even though the large droplet is falling faster than the smaller droplets, okay, so we said that terminal velocity of the big one is faster. The terminal velocity of the little ones is slow. But there's this problem, kind of like when we try to catch a feather, okay, that actually those little water droplets kind of want to sink to the side. So this just points out that even though the collector droplet should be able to gobble up everything, collision, coalescence, yeah. It's really kind of hard to collide with something when you're falling like that. Not impossible.
Until you crack.
Yeah. So,
It's creating its own air mass going down.
yeah, it creates its own wind going down, high pressure going down. Okay, so these are a series of 4 slides to kind of talk you through. Think the collector droplet or the large droplet actually is falling faster than the little droplets. And you can see it colliding and hopefully coalescing because it's getting bigger, so it must be coalescing. Okay, and then here, and not so surprising probably, rain droplets do not have that tear shape that we kind of think of as kind of, they don't.
Well, that makes sense, they flatten out.
Yeah, they do flatten out, exactly. And I've seen a video of this, and basically, they flatten out and they can get to going so much, kind of wobbling, that basically they can break apart, slow down, and actually now we have another set of cloud or collector droplets.
So accretion happens with snow and with raindrops, it's just the collision of the precipitation. How they, not collision, but how they.
Accretion, the term, I've only seen it with snow really, but then coalescence is kind of its. Oh. Yeah, I guess they are using it with both snow and with water.
Yeah.
And it probably does pick up the smaller floating ones and does it, but not the thin ones.
This is what I would have said by coalescence.
Yeah.
They grow by.
But that's kind of right.
Yeah, thanks, Autumn.
I'm confused.
Yeah. I think your confusion would be fine on the test, because I don't think I have accretion. Nope, it didn't make it. So that's good. Very good. Okay, so cold clouds, Bergeron process, right? And cool clouds, we just finished warm clouds. That's the collision coalescence process. Cool clouds are in between. So basically you can have the Bergeron process happening at upper elevations within the same cloud. You can have the collision and coalescence process going on. Okay. Just for the record. All right.
Can you go back one, just didn't get over it.
I sure can.
I was writing notes. Thank you.
So I guess you have a homework over Virga, and I'd forgotten it, but let's talk about Virga for a minute and kind of answer your homework question, shall we? Okay. So I don't know, do these clouds kind of look like they're dripping? Yeah. Clouds usually have like flat bottoms because that's the elevation or the lifting condensation level. They usually have flat bottoms. So this one is dripping, so basically it is precipitating, but it's not reaching the ground because the air is so dry. And that's part of a hint to your homework question. Okay. So with dry air, basically what it can do is that precipitation is evaporating before it hits the ground. And evaporation is it's going back into a gas. It could either be evaporating or subliming if it's ice.
That's why the clouds look, they got a little wisp on them.
Mm-hmm. That's sometimes why. Especially kind of these lower level ones. Yep.
I've seen the ones up top, where there's pouring down rain somewhere, there's no rain there.
Right. And this is doing the same thing. You can kind of see the little wispy fingers. Yeah. Which to me it looks like it stops before it hits the ground. No precip here. So here's the deal, and your homework goes something like this. Notice the word dry air here. So doesn't the homework say something about why can you not have Virga and fog at the same time? Yeah. So what are the conditions required for fog? Fog occurs, yep, at 100%, exactly, RH. And this is,
Dry air, have 100%.
right. That's it. Okay. All right. So here's kind of an assortment of things we've been talking about. Over here, oops. These first three, if it'll write for me, these first three actually separate into kind of precipitation that falls from clouds. Mist is the smallest particle, drizzle is a little bit larger, and rain can hurt when it hits you because it's going faster.
Would those do warm cloud precipitation?
Mostly. They could be, you could have the Bergeron process going on at upper elevations, but it melts, so, yeah.
Well, regular rain doesn't really bother.
What's that?
Regular rain doesn't really bother, but when it's freezing rain, it hits you.
Those pellets, yeah.
Yeah.
Yeah. I've got a slide coming up where we talk about hail finally, and hail can go very fast. And sleet and freezing rain, hopefully you're okay when we talked even this afternoon that what they have in common is a temperature inversion needs to be in place. And then rime, I don't think I've covered rime.
No,
Did
we
I
haven't
cover
yet. It's on the.
That's fancy frost, and it uses super cooled water.
Is that one?
Snow, hail. Hail's coming up. Hail and grapple is coming up.
I like that.
Soon coming up in lecture, but what they have in common, I guess I should say grapple. Hail falls from cumulonimbus clouds. All right. So a little bit about the Bergeron process, not really the process itself, but snow. How cool is snow? I always try to have you ever tried to take a picture of snow, like get the cool looking shapes and
Yeah.
It's hard.
yeah, it looks prettier to my eye than it does in the camera. So, yeah, a black jacket, it just looks beautiful. Oh my
It
gosh.
melts.
Yeah. So I'm like Joe, and I need to chase it down. I've heard that there's actually another type of snow crystal. So you can kind of see how these are an assortment of shapes that they can crystallize in, depending on temperature. It is beautiful. Agreed.
Now, can we go back, I know it might take a, but due to the shape of the crystals, isn't that what helps them interlock better than cause different types of snow?
Could be. Could be.
There's light fluffy snow, and then there's that wet stuff, it's just, I didn't know if the crystals played a part in that or not.
Yeah, I think so. There's such a range.
Depends on the temperature.
Yeah, it depends on the temperature. There's such a range of kind of qualities of snow. There, yeah, there's the slippery snow that's hard to drive on, and there's the kind of the wet snow that you like, you know.
Take it back on the lip.
Yeah, it's so heavy to
Like
shuffle.
yesterday, it was so fluffy and light.
Yeah, it was weird.
It's definitely different based upon temperature usually, or yeah, the amount that falls. But all right, so the title of this is Sleet and Freezing Rain. So let's look at look for the temperature inversion. So basically, we have a pocket of warm air that has inserted itself, okay, kind of up and over colder air, okay, creating a temperature inversion. So that means that it could fall as snow, liquefy in that warm air, and then refreeze. No. Bad. Okay, so kind of a separate from that is this idea of hail. And hail is one of when we get severe weather. Severe weather. We may or may not get hail. And so our severe weather clouds are cumulonimbus clouds. So hail is going to fall from cumulonimbus clouds. So notice some things we've been talking about. We talked about supercooled water already. Okay, basically in the cumulonimbus cloud there's liquid water that is colder than but it's a liquid, but it's colder than freezing. So basically you're going to see the hailstone go up and then down and then up and then down. So it carries the updraft, it gets larger, basically gets a coat of supercooled liquid, and then it falls down because of gravity. And then it can catch the same updraft or another stronger updraft, go up again, okay, and cycles back around.
And the grapple said it's just a little bit softer
Yeah.
ice.
Yeah, the grapple, and I don't think it's necessarily, grapple doesn't have to be in cumulonimbus clouds, but I think it's just something that can actually begin to form as hail. What?
I don't understand the definition of the word.
The grapple?
Ice cream.
Grapple is, they call it soft hail, and I think that's one of the things. Grapple is miscellaneous, it's not really an ice crystal, it's not a pretty snowflake. It's kind of an ugly looking chunk of ice, basically. Okay? And actually grapple, when we talk about lightning, grapple is a player in lightning too. So lightning would be cumulonimbus clouds too. It's little chunks of ice. So the red is the updraft, okay? And when we talk about storm clouds, cumulonimbus clouds, we're going to talk about downdrafts too, a specific area where basically the air and kind of the travel, the movement of everything is this way. So that's the downdraft. You know, the updraft and the downdraft. As long as your storm cloud is in its, what we call its mature stage, it's going to have an updraft and a downdraft. So the downdraft is where stuff is going to fall, including hail and precipitation. And your, you see a wall. So this is the path that this particular, maybe it started out as a piece of grapple. This is the path that it took, up, or down, and then up, and then down, and up, and then down, up. And so oftentimes you can kind of see this kind of, it's like a tree ring sort of thing. You can see where each trip it got a new layer of supercooled water, and it got bigger and bigger and bigger. So here's the terminal velocity information for a hailstone that is 3 centimeters, and it's not very big, a little over an inch. Okay, when it hits you on the head, James, it's going to be going 77 miles per hour.
Yeah, that, yeah.
So these ones you see the size of a softball, or,
Right.
you know, they're traveling
They are traveling.
upwards of 100 miles an hour.
Right. And if impact is how much of a dent on impact it makes is a function of speed, then speed and mass. So. Yep. And this is Fancy Frost. It's Rhine. Not R-H-Y-N-E, but R-I-M-E.
I like that.
Isn't that pretty? I could only picture this once. I don't know. It was Westland Mall had Rhine, and it was just one of those things you're out and about and you're like, oh my gosh.
One of the pictures on my slide on the little fence of that.
Yeah, yeah. Yes, great pictures. Did I tell you I got to view them? I didn't bring yours to show you back, but they are great pictures. I have had 2 photo projects, both great. So, and notice that it has super cooled water as kind of the culprit. You guys were talking about if you have fog that is like, if your fog is full of super cooled water droplets, that can leave you kind of in an ice fog. Mm-hmm. Have you ever heard of ice fog? I have.
Oh, yeah. I'm in Ohio. Yeah, I've heard of ice fog.
Yeah, I think that's kind of what this is. All right, so I won't spend a lot of time on these because none of these made it to your test. But if you are needing to measure the amount of precipitation, here's some options. Kind of getting more sophisticated as you go down. Simple rain gauge would basically be kind of like looks like a graduated cylinder, yeah, with just gradations on it. You could kind of beef it up a little bit but then you have to kind of change your gradations. But if you use a funnel to kind of make your odds a little bit better of collecting it, then you kind of adjust the gradations there. And we've talked about those ASOSs, those little huts that kind of do their own thing. Well, this is an option of what could happen in the ASOSs. Okay, so basically, you could collect the water, and it could fill. Basically, there's a little tippy thing here. It could fill it with water, and then when it's done, when it's full of water, it will tip down. It will dump its water in there, and it will click that it tipped. It will reset, and then it will start filling this side. It'll fill it up, then it'll tip, and it'll click that it tipped or set or tipped. Okay, then it will reset. Okay, go back and forth, and then you can get volume. So on its own. Okay. So whenever you measure anything, there's a little bit of wiggle room, like was that really the right number, right? There's an uncertainty associated with all measurements. And usually when you're trying to gauge how much rain has fallen, you're usually low. Okay, bias low, because it's splashing out, wind kind of being the culprit, that sort of thing. I've never done it, but at spotter training, they're looking for people. To me, this seems like a good farmer's job. But basically, they report in how much rainfall they've gotten. Yeah, does she or he? So I'm like, I just don't have the patience. That is so cool. That is so cool. Snow, they try to have people kind of be able to call in about snow, but snow is a tough one. Because, they'll say, well, how much snow did you get? And I'm like, it's hard to tell if it blows at all, right? Yeah. Down here at the bottom, if you ever kind of thought, it's raining, but I'm sure glad it's not snow. So here's kind of the equivalent. In general, you say in general that 1 inch of rain, if it had fallen as snow, it would have been 10 inches of snow. 1 inch of rain, 10 inches of snow. But that's really broad, depending upon temperature.
So we're talking about Boston having 100 feet.
100 feet of snow. Oh my gosh. So that would be 10 inches of rain. No, 10 feet of snow. 10 feet of rain.
That'd be more than that. At 100 feet, 10 inches.
If it's a 10 to 1.
You're talking about, huh?
100 inches, 100 feet.
But that's a lot.
It's still a lot, but
Still a lot.
I was like, wait, it wasn't 100 feet. They don't be that.
They can stop anytime, I'm sure.
You don't want 100 inches of snow around here?
I don't know.
How much sense in a bench?
Nothing will be open.
What's that?
You got 100 feet of snow, nothing will be open.
Yeah.
100 foot of snow would like,
100 foot of
All
snow
the
would be
roofs would cave in.
Yeah, they do
the
a weight
apocalypse.
ratio.
I think they will tell everybody that lives in Keokuk, get out.
You know how we could accidentally get 100 feet of snow? If somebody asked his or her genie to do it. Oh. I dream of genie. Roger used to ask for the dumbest things.
Seriously. I guess if you just had one around all the time, though, you know.
Yeah, I
then you
know.
would start to ask for
Genie.
stupid things.
Yeah. Okay. So instead of like physically being there, the next best thing is maybe something like this. This is a way to probably recognize, this is showing you precipitation. The angrier the color, the more the precipitation. And we'll be talking more about weather radars, but just to kind of introduce you to the idea. You see the word echo up here. So basically, what a weather radar does is it sends out a signal, and if it's not precipitating, that signal just doesn't ever come back. Okay? So if it is precipitating out there in the distance, what will happen is that signal that it sends out will return. That's the echo part. Okay, so they're looking for it to come back. Now, if it's really raining hard, basically they'll get their full signal back. Okay, it's like a wall of water. Yeah, and they translate that to the ugly color. But the one thing I think is so neat when I look at, because you know, you're like, oh my gosh, there's kind of like a band of rain and then lighter rain, is this is multiple radar stations working together. Because basically radar can only go so far, okay, for the reflectivity or the echo.
Line of sight.
What's that?
Line of sight.
Line of sight, exactly. If there's hills here, they're like, it's not happening, right? So this is a composite radar. So basically multiple radar images come together. So, exactly. All right. So if you've ever wanted to change the weather, this is for you. How many people have Netflix in here? Yeah, I like Netflix. I don't know if they still have, but there was a document on Netflix about weather modification. So if you just go into weather, type weather or modification, and it was pretty cool.
Just makes me have a chance of people.
The government did try to implement a program to challenge the
HARP?
weather.
Is
You
it
know about
HARP?
HARP?
Yeah,
Okay.
yeah. And I don't think,
High intensity animal.
yeah, HARP, I don't think it's necessarily a dead project, is from what I understand, but I'd have to look into it. I don't know. But these are the normal things, aside from HARP, I guess. One is that you can use something like helicopters, use your own energy source to make something happen, move air around. Another is that you can we looked at two houses, like back in Unit 1, and we looked at the reflectivity of the house with a white roof or a black roof. I mean, that's a way for you to modify. If you live in cold places, you want a dark roof. If you live in warm places, you want a light roof, right? And then the other one is basically try to stimulate the atmosphere to do something. And we're going to look at a plane that basically is trying to seed the atmosphere to begin condensation, called cloud seeding. So, what's that?
Silver iodine.
Yep. Silver iodide. It could be silver iodide to try to kind of get the party started, to provide these very water-loving, hygroscopic sort of cloud condensation nuclei. Okay, to begin. But you're going to see on the next slide that the clouds aren't very stable necessarily that we get from that. So the whole idea of forcing it to precipitate where Mother Nature otherwise did not want to precipitate is kind of at the bottom you see, is that really fair? Okay, it's like robbing from Peter to pay Paul sort of thing, you know. But if you watch those apocalypse movies, you're like, you know, the every man for himself sort of thing in some of those cases. I don't know. So, I hope it never comes to that.
Mine's predicted wrong 3 years ago. So.
What's that?
Mine's predicted wrong.
That's right.
Who says that's what they
Yeah, the Mayans,
Sounds like you just
some
went on a
people's
room.
interpretation of what the Mayans
Yeah, I'll
said
say,
to
it's depending on how you interpret
Yeah.
it.
Yeah, some would say that Mayans never meant to do that. It was interesting, though. I like that
There was like a
end of their
Far
calendar.
Side kind of, wasn't Far Side, it was
2012, right?
Rebels
Yeah.
or whatever the other one was.
I,
And it was, they like were showing it, and he's like, well, how come you only went to December 21st, 2012 or whatever? And he's like, I ran out of room.
Yeah.
It
Yeah.
was one of those-
It's
Her
interesting.
and I are old enough to remember the Y2K scare that the world was gonna end.
Yeah, I filled my bathtub with water on December 31st, 1999.
Did you
Yep.
really?
Did not have the shotgun. My family says I had a shotgun. I didn't have a shotgun. Guarding my water at bathtub. Yeah.
That was a big scare though.
That was.
Didn't know what was gonna happen.
So you can kind of see the clouds down there are kind of don't look very stable. Okay. All right, almost done. We're just gonna, we'll just finish up this chapter. We won't start 16. Okay, so this did make it to the test, and I think the only thing I'm after here for this subject is hailstones fall from what kind of cloud? Cumulonimbus, exactly. That's not what I want from this test. But, let's see. I think it's on the next one. Why would you want to, what around here, why do we not like hail? The damages, yeah. Yeah, cars, houses, fields, exactly. That's why we want to control
So
hail.
what, hail suppression?
Hail suppression. Why hail suppression? To I think
Damage
save our
to the
plants,
insurance,
yeah. To save our stuff. What were you saying, Jim?
If they're big enough, you can play with them.
That's right. No, I don't want to be out there, after it's, the hail shaft has moved on, then I'll go out and kind of handle
No, I'm saying after, not during.
It interest people really bad.
it. They can really, yeah. So I don't know how big these are, but they look plenty big to,
They came down more than 70 miles an hour.
yeah. So this is why we want to control hail. Now, this actually is, does it look like a snake oil salesman talking
Oh, yeah.
to her? Maybe she's talking to him, saying, maybe you should buy this thing. So this was basically, and I think it didn't ever necessarily work, but to try to kind of boom up in the cumulonimbus clouds to disrupt the formation of hail. If you were desperate. I don't know. So the last topic is, it's not necessarily modifying the weather, but modifying the temperature around your precious fruit or precious crops. So white frost, to me, and I was thinking about this, to me white frost is usually what we see, white frost in the morning. You know, it's just normal frost. White frost is normal. So, how can you protect your crops if the temperatures are going to fall below freezing? Well, here's an assortment of things. Well, that makes sense, right? You could cover them, and you're hoping to try to trap that warmth from the ground. Notice that one way you can cover them actually is to basically have, this talks about smudge fires, I know. A smudge fire's particulates to try to kind of trap that. Sounds dirty, but if you're desperate, you don't want your stuff to freeze. Another one, this seems kind of controversial, is maybe you can purposefully like sprinkle your fruit with your liquid.
They do that more. They do it in Washington too, on the apples and stuff like that. And I know this because I work up in Washington on an apple farm. And what happens, because the apples and the fruits have a chemical reaction and cause their own internal heat.
Okay.
So you encase the fruit inside the water, keeps the heat
So it's
inside.
successful.
Yeah. And then you can,
It seems counterproductive.
It seems weird, but it
has-
saves your fruit.
it saves the fruit, but it has the effect after it melts, it also saturates your air around with water, so the water draws back up into the tree and leaves in the tree
neat.
because of photosynthesis and absorption absorb the water back into the tree.
That's neat. I could see that. I like that. And then the last one up there is basically, the last two is mixing warmer air. If basically you don't have any clouds and basically it's petered out to bring that warmer air
Heated
back
water.
down. or to throw in the heater. Okay, so that's good. We'll knock out chapter 16 on Wednesday.